Once we know how many different things can happen, we can turn our attention to the probability that any one of those outcomes actually does occur. There's three different types of probability that we're going to look at. The first is the classical or theoretical probability. And this is used when each outcome in a sample space is equally likely to occur. For instance, flipping a coin, the outcomes of heads and tails are equally likely. They're both about 50%. The classical probability for an event is found this way. The notation we use is capital P for probability, and then in parentheses, we put the event that we're calculating the probability for. And all you do is take the number of outcomes in that event. So the number of outcomes that satisfy your event and divide it by the total number of outcomes in the sample space, which we now know how to determine. The empirical or statistical probability is based on doing actual experiments. So I tend to remember empirical is sort of experimental. The empirical probability is given by actually performing the experiment and looking at the frequency of the event you're interested in and dividing it by the total frequency. And I've also written that in two different ways symbolically. Subjective probability results from intuition, although more so than intuition, we hope it's educated guesses and estimates. So this would be a case where I might say, based on how you did on your last test, the possibility of you passing your next one is probably 80%. In example 8 in your textbook, we are asked to classify each statement as an example of either classical, empirical, or subjective probability. The first one that we are presented with is the probability that you're going to get an A on your next test. If you're going to say that it's classical probability, getting an A would have to be equally likely to getting a B, getting a C, getting a D, getting an F, which is not true. To be empirical probability, it would need to be based on some sort of data that you have collected, which isn't mentioned here, so probably not that. It's more likely a case of subjective probability. So this one is subjective based on an educated guess. The probability that a voter chosen at random will be younger than 35 years old is 0.3. So once again, we have to decide classical, empirical, subjective. The probability of choosing a voter at random younger than 35 does not have equally likely outcomes. So it's not classical. It's either going to be empirical or subjective. And if we are looking at choosing a voter, it's likely that this was based on a sample where we actually collected data. That's called doing an experiment, and that would be empirical probability. I am assuming a sample data set was collected. If you were just to walk up to me and ask me my opinion about the probability of a voter being younger than 35, and I just give you a number off the top of my head, that would be an example of subjective. And lastly, the probability of winning a 1,000-ticket raffle with one ticket is 1 out of 1,000. Now, in this case, we know how many outcomes we have. If it's a 1,000-ticket raffle, there's 1,000 different tickets that could be drawn to be the winner of the raffle. And each outcome should be equally likely. So I reach in, and each of those 1,000 tickets has an equal chance of being chosen. If it has an equal chance, then we know that this is classical probability. And again, that's because all outcomes are equally likely. Now, you've seen some ways of representing probabilities here. We have a decimal, a fraction. Probabilities can be expressed as fractions or decimals, but also percents. And they will always have a value of 0, 1, or a number in between 0 and 1, or in the case of percentages, 0 and 100. So here you see the probability scale. Any event that is impossible, not going to happen, we assign a probability of 0. So the probability that I'm going to win the lottery today is 0 because I'm not going out and buying a lottery ticket. Anything that is certain to happen, we assign the probability of 1 or 100% if we're talking about percentages. Now, in this case, there's a 100% chance that I am going to have lunch soon because it's getting to be that time of day. So anything certain to happen, we give that probability of 1 or 100%. And then from there, right in the middle are things that have an even chance of happening, a 50-50 shot, you'll hear people say, of something occurring. That can be represented fractionally by 1/2, as a decimal by 0.5, or as a percentage by 50%. If you're somewhere between impossible and an equal chance of happening, that's more towards the unlikely side. So these are going to be numbers between 0 and 0.5. Things that are likely to happen are going to be approaching 1. So it'll be somewhere between 0.5 and 1. So in this instance, I've just given examples of unlikely or likely. They don't have to be these numbers. Any number between 0.5 and 1 is considered likely to happen. So let's practice finding probabilities in each of the different ways. So you roll a six-sided die. Find the probability of each event occurring. All right, when you roll a six-sided die, assuming it's a fair six-sided die, all the outcomes are equally likely. So this is going to be a classical probability. If we go back to our types of probability, you can see that classical probability calculates the probability of an event by taking the number of outcomes in the event divided by the total number of outcomes in the sample space. So first I need to know my sample space. What are all the things that can happen when I roll a six-sided die? I can get a 1, 2, 3, 4, 5, or 6. My probability of any event So in how many different ways can I roll a 3? How many sides are labeled with a 3? There's only one. So my numerator for this fraction is going to be, there's one way to roll a 3. How many total outcomes are there when you roll a six-sided die? There are 6. So I can express the probability as the fraction 1/6. I can also pick up a calculator and get the decimal equivalent, which is approximately rounded to 2 places 0.17. So we have a number between 0 and 1. And I can take that number and multiply it by 100 to get the percentage. So that has about a 17% chance of occurring. In number 2, you're asked, what's the probability of rolling a 7? Well, look at the number of ways the event can occur. Is there any way you can get a 7 rolling a six-sided die? Not if you're only rolling it once. So therefore, there's no way that can happen. 6 possible outcomes. That's, of course, 0, also known as 0%. And so what we've just found is that this is an impossible event for this situation. And the probability of rolling a number less than 5. When you make this fraction, the number of ways that event can occur, there are multiple. Numbers less than 5 would include 1, 2, 3, and 4. So in this particular instance, there are 4 different ways that might happen out of 6 possible outcomes. And so therefore, my probability is 4/6. Now, you can reduce the fractions, although sometimes when doing probability, it's better not to. But it is okay if you do. You can pick up a calculator, get the decimal approximation, which to two places would be 0.67. And then again, just by multiplying that by 100, you get the percentage, which would be a 67% chance happening. So because the percentage chance that this occurs is 67%, that puts it into the likely category because it's between 50% to 100%. Now, you probably have done probabilities like this in high school. This is fairly standard introductory stuff. What may be less familiar to you is doing something like example 6. A company is conducting an online survey of randomly selected US adults to determine how they read books during the past year, if at all. So far, they have surveyed 1,490 adults, and the pie chart shows the results. What's the probability that the next adult surveyed will read only print books during the last year? In this case, because a survey has been performed, that's an experiment, and that means this is an empirical probability, where you have actually gone out to collect data to see what happens. So if this is empirical, we calculate the probability of any event by finding the frequency of that event and dividing it by the total frequency. So the probability of a person who read only print is going to equal the frequency of reading only print materials divided by the total frequency. And the total frequency is just the n, it's your sample size. You can add up all the individual frequencies that are shown in the pie chart. There's a couple different ways you can get that number. But definitely our denominator is there were 1,490 people total in this survey. The frequency of reading only print books can be found right here in the pie chart, which was 578. So that would be the probability expressed as a fraction. If you pick up a calculator and type that in, it should turn out to be approximately 0.39. And multiplying that by 100, that's 39%. So because 39% falls between 0 and 50%, we would consider that an unlikely outcome. Fewer and fewer people, it seems, are reading books in traditional formats. All right, here's another example. A company is conducting a phone survey of randomly selected individuals to determine the ages of social networking site users. The frequency distribution below shows the results. What's the probability that the next user surveyed is going to be 23 to 35 years old? Because we have actually conducted a survey and collected data, this is going to be empirical probability. So if I want to know the probability of the next person being 23 to 35, I need to know the frequency for that age group, and I need to divide that by the total frequency. So the frequency of a person reported to be 23 to 35 years old is this row in the table, 312, divided by, now in this case, they didn't tell me how many people they surveyed, but using the information in the table, I can go ahead and sum up all of my frequencies, and that will give me my sample size, n, which becomes the denominator of my fraction. So if you add up those numbers, you should get 975. That's the fractional probability. And when you figure that out on a calculator, it turns out to be 0.32. And therefore, that's equivalent to 32%. So again, this is a relatively unlikely event. The last concept in this introductory section is how to determine the complement of an event. So once we know the probability that something does happen, what's the probability that it doesn't? So the complement is the set of all outcomes in a sample space that are not included in the event you're focused on. The complement is denoted by this notation, E with this little apostrophe on it, which is a prime. So we read that E prime. And since the sum of the probabilities of all outcomes in a sample space needs to be 1 or 100%, we can find the complement of any event by taking the probability that something does happen, subtract it from 1, and that'll be the probability that it doesn't happen. So in example 9, we're looking at the same frequency distribution from example 7. So suppose in this instance, I want the probability of a person who is not 23 to 35. What our formula above for the complement says, if you want the probability that someone is not 23 to 35, you're going to find that by doing 1 minus the probability that somebody was 23 to 35. We calculated that number up above. That was 0.32. And 1 take away 0.32 is going to be 0.68 or 68% chance. So there is a 68% chance that you select somebody who is not 23 to 35. You could also verify that by totaling up all of the frequencies for being not 23 to 35. If you total those numbers up, you're going to get 663 out of 975, and that'll give you the exact same answer. But usually you can see how it's less complicated since we already knew the probability for 23 to 35. It was a simpler calculation just to subtract that from 1 than it is to add up all of these numbers again, redivide them, and get the answer that way. But they both do work. So that's your introduction to probability.